will be starting in a while. At 10 a.m. we will start the session.
Good morning and welcome to one and all present over here for day 9 of our capacity building program on research methodology. Today we are having with us Dr. Madhukar Darvi sir. Yesterday sir already started with parametric test 1 sample and 2 sample. Today again sir will continue with the same topic based on ANOVA. Sir is the head of Department of Mathematics of Nagindas Khandwala College. He has a total of 27 years of teaching experience. His specialization lies in mathematics, statistics, and operational research. He has total 17 research papers published and one UGC-funded minor research project is completed. Sir has also provided consultancy to 82 research scholars for research data analysis. Sir, we are happy to have you here again today and we look forward to your session ahead. Thank you.
Thank you, Mr. Madam. Good morning, everyone. I think, am I audible clearly? If I'm audible clearly, please.
Yes, sir.
Yeah, okay. We'll straight away start our session and continue yesterday's topic. Let me recall something which just check whether my slide is clear. Yes, please reply.
Yes, sir, it is visible.
Right? Okay, thank you. Yeah, so let me, we started with the first part. What are the different statistical tools applicable in the research? Whereby there are two types of statistics, descriptive statistics and inferential statistics, I said. And then descriptive statistics for objective verification we utilize, mean, median, mode, type of things are statistical tools are used deals with hypothesis testing. And there are different. Then we have seen how to install software called as Jamovi, which we'll be using and continuously using today. After that, started with hypothesis concept, and the idea of hypothesis testing, why hypothesis testing is required, the purpose behind that, types of hypothesis, which includes research hypothesis, statistical hypothesis, null hypothesis, alternative hypothesis. Basically, what I said in the last session was the relation, the hypothesis type, there are two basic types, which are relationship type hypothesis and difference type hypothesis. Okay, these are very important because whenever we test, we should understand this concept very clearly. Then directional and non-directional, I think this was also very clear, right? So this also you have to understand because your statistical test value will actually depends on this, whether it is directional or non-directional. Please remember, our hypothesis, research hypothesis, is always alternative hypothesis, and null hypothesis is an opposite statement, may not be a negative statement. Then can hypothesis be proved? No, we cannot prove hypothesis. What we can do is we can just reject it or retain it. This you have to remember. And the null hypothesis is always assumed true, and we try to sort the contradiction or get the contradiction to reject that hypothesis. At the end of the session, I spoke about type 1 and type 2 error, which was actually dealt by some other resource person also. Type 1 error is rejecting null hypothesis when it is true. Remember that in the testing process, we always test null hypothesis. Alternative hypothesis is an ultimate outcome after testing. That is, if you reject null, then alternative is accepted or retained. And if you accept null, then alternative is rejected. While doing this, there is a chance of error. Now, if null hypothesis is rejected, which is actually true, then it is a type 1 error. I said that time that अगर हिंदी में बोलेंगे तो सच को झूठ मानना is type 1 error and झूठ को सच मानना is type 2 error in the simple language. Then I said about hypothesis testing type. That is, it is one-tailed test or two-tailed test. How do we decide this? It depends on the direction, whether it is one-sided. For example, if it is, and everything depends upon your hypothesis. That is the direction of the hypothesis testing. Direction is decided based on alternative hypothesis. That is our original research hypothesis. Suppose our original research hypothesis is something less, smaller, like that, then it is left-hand side test we are going to apply. And if our hypothesis is greater than type, alternative hypothesis, so the direction of the hypothesis is decided based on alternative hypothesis. That is our original hypothesis. If there is no direction, then it is called two-sided test, or in the simple language, it is non-directional hypothesis. Very important before we start our today's session. Listen until you understand. Then I spoke about significance, the word significance. Different. These are two different terminologies.
Sir, maybe the bandwidth is low. If you can switch off the video, maybe it can improve.
That is, we always keep. Yes. Okay. Fine. Fine.
So you're on mute.
Am I audible clearly now?
Yes, sir.
Is it okay? Still my voice is cracking?
No, sir. The voice is
audible
fine.
Clearly? Fine, no? Yeah, thank you. Yes, so I was talking about error. We always keep a margin of error, and that margin of error is generally considered as 5%. We call it as level of significance. That is nothing but the margin of error. What does it mean? Let's try to understand. So whenever we test any hypothesis, uh, after testing, right, we should say that we are 95% confident, but there is a chance of error. And that how much chance of error? 5% chance of error, because there are different types of errors also. For example, there's one type of error called as sampling error. The respondents may not respond in a proper way. We don't understand as a researcher whether respondent has given a proper reply. So we always keep a margin. So when we finally conclude, we always say that we are 95% correct or confident in our testing, but there is 5% margin. As far as the scientific research is concerned, this 5% is huge. This much margin is not allowed. So for scientific research, whenever we go for testing in science, we don't take such a big 5% margin. We always keep 0.01 or 0.1% margin, not more than that. Right? A very small margin is used for the scientific research. And now this is actually the diagram which indicates there are two-sided tests. So what happens is whenever we talk 3% and 5% margin of error, this 5% for the two-sided test, that is non-directional hypothesis, this 5% is divided in two parts, 2.5% and 2.5%. So this portion is 2.5% and this portion is 2.5%. And that's what I said, the direction is very important, whether it is directional or non-directional. If it is just non-directional hypothesis, say for example, directional hypothesis, then the whole 5% is taken here, whole 5%. This alpha is nothing but that significant level. So whole 5% is taken on the left-hand side. So your rejection region, so this is the rejection region. Rejection of null hypothesis, that region changes. So the important part you have to remember is you have to decide about the direction of the hypothesis. Okay? And while testing also, you have to specify the direction of the hypothesis. Generally, in social sciences, we take 10%, 5%, 2.5%, or 1%. 2.5% is that half of 5%. So we take 10%, 5%, and 1%. But in most of the cases, 5% significant level is accepted. So for social science, 5% significant level is accepted everywhere. 10% in a very rare scenario. 1% is always better. 1% in the sense we are 99% confident. We are only 1% margin of error. So obviously, if it is 1%, it is always better. Statistical hypothesis testing software will help you in deciding the significant level also. But initially, actually, we have to set up a level and we have to start. We may change it also later on. Okay. Now, with this, let us start today's session with the steps of the hypothesis testing. We'll understand, first of all, how do we actually start testing, hypothesis testing? We have to set up null and alternative hypothesis. How do we do this? I told you in the yesterday's session. Alternative hypothesis is your original research hypothesis. Read that hypothesis very clearly and find out whether it is relationship type or difference type. Then opposite statement of that null hypothesis, opposite statement of that alternative hypothesis is your null hypothesis. Null hypothesis need not be negative. Again and again, I'm telling you this. Then select a significant level. So decide, you want to test at 5% level or 1% level. You may change this later on after testing also. Right? If you find that you can still work out with 1% level, then it is always fine. 1% is always better than 1% is always better than 5%. Remember this. Then we have to for normality. Today, our first part will be testing normality. So we'll go for test of normality. After testing the normality, we decide the type of test which we are going to apply. In fact, if the data is normally distributed, If the data is normally distributed, we use parametric test. And if data is not normally distributed, we use non-parametric test. I am going to talk about those things. So we decide about test after the normality. Then we use software, we calculate the test value of the data. Test value, what is test value? T value. If you are applying T test, it is T value. If you are applying man-Whitney U test, it is U value. If you are applying ANOVA, it is F value. So we find out the test value. And at the same time, we calculate P value. What is P stands for? Probability. P stands for probability. Okay. Now this P value concept is very, very important. In yesterday's session, when Sir was Patil sir was Sir Patil sir was discussing the SPSS software, he spoke about this test value. Okay. But the P value concept is very popular nowadays, and it's common. Like you need not go for tables, statistical tables. You just have to look at the probability value and compare with the significant level. P value probability is always 0 point something, and 5% means we can convert into decimals also. 5% is equivalent to 0.05 probability. So we compare with these two numbers, right? Actual calculated value and the standard significant level, and then we decide about the test. Now, how do we decide what is the decision rule? Accepting and rejecting null hypothesis. How do we decide? P value. What is this value? P value. This is calculated P value. That is, we use data, we calculate P value. If calculated P value is less than chosen significant level, then null hypothesis is rejected. See, when we test, either we reject null hypothesis or we accept. But remember, now I am not going to use terminology accept. Instead of terminology accept, I'll be using terminology called as retain. Statistical language, we do not use accept as a term, we use retain as a term. So we retain or reject. Both are, either we retain or we reject. So either we retain or reject. So how do we decide what is the rule? Rule of rejection. Rule of rejection, null. We want to reject null hypothesis, right? So when we want to reject null hypothesis, what is the rule of rejection? Well, calculate P value from the data using proper statistical test, appropriate statistical test. Then, if that calculated value is less than chosen significant level, chosen significant level is either 5% or 1%. If it is less, then we say that yes, the null hypothesis is rejected. If null is rejected, okay, just keep this rule in mind so that we will use this continuously while testing. Now, tests are classified as test of association. Association means relation. So there are tests related to association. For example, your Pearson test, Pearson test, then your regression test. These are actually tests of association, or even chi-square test is considered as test of association, and test of differences. Differences where the hypothesis is talking about significant difference, right, between the variable or among the variable. That time we apply. So here in this category, we are having t-test, ANOVA, etc., etc. So those t-test and ANOVA will be discussing today, which are. So our focus in the today's presentation will be test of differences. Other tests I may not consider. Okay. Yes. Now, test of normality. What is normal? There are different ways of testing normality. First thing is we calculate the values of skewness and kurtosis. Okay, using skewness and kurtosis. Skewness and kurtosis, in the yesterday's session when I've taken you to the software, we were having descriptives, and under descriptives, skewness and kurtosis, along with the standard errors, we have to calculate those things. Then calculate Z value. Z value is calculated by dividing skewness by its standard error. You get Z value. Same time, we divide kurtosis by its standard error, get Z value. If Z value lies between this two number minus 1.96 and plus 1.96, then we say that data is approximately normally distributed. Most of the time, 100% normal distribution data you don't get, right? So we say approximate, but general terminology you say that data is normally distributed. Then we can use QQ plots. Here, it's not that clear sometimes. Clearly, one cannot say that using QQ plots one can get a data, but I will show you how to just understand. Histogram, again, this I have shown you yesterday. The direction of the density curve along with the histogram, those bars will decide whether the data is normally distributed. The last part is very important. We are having one test called as Shapiro-Wilk test. Now, the Shapiro-Wilk test will decide whether data is normally distributed or not. A p-value, how to decide what is the rule? P-value for Shapiro-Wilk test is greater than 0.05, then we say that data is normally distributed. Give a little time, then we will go for actual finding out with an example. Okay, now very important, everybody will focus here now. What we have to do is, whenever we start any testing, first step is what? Framing null and alternative hypothesis, then decide significance level, then go for normality test. After actually doing normality test, you will understand whether data is normally distributed or not. Suppose your data is normally distributed, then we apply parametric test. So when do we apply parametric test? For normally distributed data. Remember this. Parametric tests are applied for normally distributed data, and non-parametric tests are applied for not normally distributed data. They not be normally distributed. In the sense, when data is not normally distributed, we use non-parametric test. Okay. Please remember that even if data is not normally distributed, there is nothing wrong with your research. Right? You are doing research properly. You have collected a data. Data may be skewed. The responses may be one-sided responses, but that does not mean that you are wrong. But still, if you feel that there must be something wrong, then you have to check your data, right? But if you are applying non-parametric tests, that does not mean that your data collection is wrong. Please note this, because I have seen some people argue. They said that data is not normal, so there is something wrong with my research. Like another type of test, which is very similar test. It's just like, if you happens to have fever, right? You go to your doctor, family doctor, and doctor will ask you to go for a test. If test is positive, say for example, doctor feels that you are having malaria, then doctor will suggest to go for a malaria blood test. After blood test, either you are having a malaria or you are not having malaria, right? So if you are having malaria, another type of medicines will be taken. That is one type of testing. And if you are not having malaria, another type of testing. So it is like that. So nothing wrong. Okay. So if it is parametric or non-parametric. Now let's try to understand further. Look at the top part of my screen. What is written on the top? Testing difference from the benchmark value, right? Testing some five-point agreement scale. We have 5-point agreement scale. Now, in the 5-point agreement scale, that is strongly agreed to strongly disagree, and midpoint is the neutral part, right? So what we do is we fix neutral benchmark. If anything greater than the neutral point, a value greater than the neutral point, right, is considered as agreement. Anything less than the neutral point is considered as disagreement. So we have a one benchmark value. So what we do is we compare our data with this benchmark value, the calculated value with the benchmark. If we calculate this with a compare with the benchmark value, and we are trying to find out a difference whether my mean value of a data is greater than the benchmark value or less than the benchmark value or equal to the benchmark value, or compare, just check whether it is significantly different than the benchmark value, then we say that in that case we actually use one sample. So what is one sample? Now please try to understand when we use one sample. One sample test is used only when there is a single sample, and that sample mean we have to compare with one benchmark value. Another example I like to give, we know that we drink cold drinks, right? And there is, say, for example, there is a small bottle of 200 ml cold drink, and there is a glass. Now, what is expected that in that glass, 200 glass, the cold drink obtained should be 200. But suppose it is something wrong, so check whether it is really 200 ml or not. What do we do? Then we 200 is a remark, and any less than that, we send it to 200. Like that, sometimes there are benchmark that is called as. So this is one that is used when data is parametric. When data is non-parametric, we apply Wilcoxon rank test. This is non-parametric. Both work in this similar way. Software, they are actually calculated in the same place, right? We just have to select an option. Select an option that is first, depending upon our take, and then we apply. If the sample size is generally cases use sample size or unknown variance. What is unknown variance? Unknown variance means standard deviation is not known. Variance is standard deviation is not very variance is not given. In that case, is applied. In most of the cases, is not given. We apply 99%. Hello.
So the screen is
Am I audible? Should I continue?
So
Yeah.
there is some
I
technical
think
glitch. We will resume soon. Just give us 2-3 minutes.
yes. Okay. Okay. Fine.
So has the lab assistant reached the geography room? There is some technical glitch. We'll resume soon. Participants, today we will be having 3 sessions. The last 2 sessions would be in our language. So Sonali ma'am has shared a document and has asked to download the R language software. Hopefully every participant have downloaded that, because that would be required for the last 2 sessions which we'll be having today. That is session 2 and session 3. So till the time in, kindly download that particular software, because sir would be like taking a demo of that particular thing for our language session. And it is expected that you, for the session 2 and session 3, you log in via 2 devices, one through your laptop and one through your mobile phone. That is the instruction given to us by the resource person. So kindly download the software and log in via 2 devices, one through laptop and one through mobile phone.
Sir, you can share your screen.
Yes. Am I audible now?
Yes, sir.
Screen is visible, madam?
Screen is visible, sir.
Okay. Thank you very much. Sorry for interruption, internet issues. Yes, what I was talking, there is one sample test for whenever we have to compare with a benchmark value, we use one sample test. For parametric data, that is normally distributed data, we apply t-test, and for non-parametric data, we apply Wilcoxon RAM test. Suppose we want to find out a significant difference between two groups, right? Comparison of two groups. Say, for example, marks of boys and marks of girls, right? Scores given by for the boys and girls. If you want to compare two groups, whether there is any significant difference. Of course, for the difference, then if the data is parametric, then we apply t-test again. But there are two types of t-test here: paired t-test and independent sample t-test. What is the difference in paired t-test and independent sample t-test? Paired t-test is applied for paired data. That is when data is paired. Paired means, let us take an example before and after. Boys and girls के लिए boys group and girls groups are, boys and girls के लिए boys groups are, boys and girls के लिए boys groups are. Before and after, boys and girls के लिए boys groups are, boys and girls के लिए boys groups are. Before and after, boys and girls के लिए boys groups are, boys and girls के लिए boys groups are. Before and after, boys and girls के लिए boys groups are, boys and girls के लिए boys groups are. Before and after, boys and girls के लिए boys groups are, boys and girls के लिए boys groups are. Before and after, boys and girls के लिए boys groups are, boys and girls के लिए boys groups are. Before and after, boys and girls के लिए boys groups are, boys and girls के लिए boys groups are. Before and after, boys and girls के लिए boys groups are, boys and girls के लिए boys groups are. Before and after, boys and girls के लिए boys groups are, boys and girls के लिए boys groups are. Before and after, boys and girls के लिए boys groups are, boys and girls के लिए boys groups are. Before and after, So we are independent. But in certain cases, we perform experiment before and after. Before conducting a particular program and after conducting a particular program. Maybe suppose we want to compare whether there is any effect or not. Right? Or before conducting an experiment and after conducting experiment. Or in certain fields we use say control group and experimental group. So there we go for paired t-test. Paired means what? Same individuals are taken into the consideration before and after. So there is a relationship. So we have to go for paired t-test. Z-test is again used for large sample. Large is greater than 30. And most of the time we don't use Z-test nowadays. If data is not normally distributed, then for pair data, we apply Wilcoxon test. Only the normality changes. So pair t-test will be replaced by Wilcoxon and independent t-test will be replaced by Mann-Whitney's t-test. You need not remember all these things. Please note, you need not remember all these things. Automatically, the only thing is you have to understand name of the test you did not remember, but where to apply this type of test, this basics, if you understand, then it is okay. Suppose we are having more than two groups, and again we are finding the significant difference. More than two groups. Then for more than two groups, suppose there are three groups, three divisions, three classes. If you are comparing the marks of three divisions, students for three divisions, then 3, 4, 5, whatever it is. Then we apply for parametric data, we apply ANOVA, and for non-parametric data, we apply discrimination. So we have to see. So all these t-tests, pair t-tests, independent t-tests, ANOVA, these are all parametric tests. And all these are used for examining differences. So whenever you want to examine differences, these tests are used. Right? For examining the strength of relation or association, two or more variables, if data is parametric, then we apply Pearson correlation. If non-parametric, we apply Spearman. We are not going to discuss much about this, but you should know this. Further, if you want to find out whether one variable depends on the other variables, then we apply regression test. That is for parametric data, normally distributed data. If there are categorical variables, data is not normally distributed and there are categorical variables or attributes, and we want to find out the relationship between categorical variables. Educational qualification, educational levels, and gender. These are all these categorical variables. If you want to find out the relationship, we apply chi-square test. This selection of the test, choice of test is very essential to understand. Now let's go for Jamovi. All these steps we have discussed. So we'll begin with test of normality. Now, test of normality, there are three different parts. In fact, 4 ways we can test the normality. 3 ways I am going to show you. So let us take an example. So now we'll go for a process. First one, let us take one file. Now, for Jamovi file, our extension is OMB. OMB is an extension for Jamovi file. Please note this. So let me start with Jamovi file now. What I'm doing now, I'm testing the normality of my data, whether my data is normally distributed or not. So this is a simple data of pH value. pH value, which I was discussing in my hypothesis. pH value. Now, how do we test normality of these pH values? Let's try to understand how do we check normality of these pH values. Let's see. So what we do now, stepwise I'm going. We'll go to exploration. In exploration, we'll go to descriptive. We'll go to descriptive. If anybody is trying, please try along with me. Open a file called as pH scores. The name of the file is pH scores. Just transfer this variable pH on the right hand side in the variable box. Then go to statistics. Do not select anything here. go to statistics, and in statistics, you don't require this minimum, maximum, nothing. Even standard deviation is not required. Just keep this n and missing values because they are required most of the time. Select skewness, kurtosis, because we are going to apply first one is kurtosis and skewness concept. Then Shapiro-Wilk test. This is a Shapiro-Wilk test which we are going to apply. So we'll get this type of table. And after that, we can select a box plot or histogram, QQ plot, and density. So this thing. So let me once again explain what you have to do. The original variable is on the left hand side. Just transfer that variable in the variable box. Then select skewness kurtosis, Shapiro-Wilk test, histogram density, and filter plots. So all these things are available with us now. On the basis of this, you have to decide whether data is normally distributed or not. Ideally, no need to go for all these things. You just have to select Shapiro-Wilk test. If you just select Shapiro-Wilk test, then also you will be able to understand how to go for normality. So let's go for it. How do we decide normality? First of all, skewness and kurtosis. So what is the value of skewness? 0.729 minus 0.729. Doesn't matter, minus or plus, divided by its standard error. So what you do is you take this value and 0.9 divided by 0.564. That will give you Z value. If you divide these two numbers, you will get Z value. Similarly, take kurtosis value, divide by its standard error, right? What you get again is Z value. There are different approaches. One is using skewness, other one is using kurtosis. Okay, and check out what answers you are getting. If your answer is between if your answer is, Z value calculation is already done here. Skewness value divide by value. We divide this and we calculate Z value. Z value lies within this. Z value lies between minus 1.96 and plus 1.96. So we say that data is normally distributed. So in this case, we are getting answer minus 1.29, which is here, right, between these two numbers. So we say that data is normally distributed using skewness test. Similarly, kurtosis, divide. So these two numbers, these two values are divided. 0.379 minus divided by 1.09, we get this value. Again, this value lies between those two numbers, minus 1.96 and plus 1.96. We say that data is normally distributed. In some cases, we get different results from different tests. In that case, we'll have to say that data is not normally distributed. In this case, both the tests have given the same result. So what is your conclusion? Data is normally distributed. So what we have to do once again, find out skewness, find out its error, divide, find Z. Z is between these two numbers, data is normally distributed. Then find out kurtosis, divide. Now with software, this is very easy. With software, this is very easy. Okay. Yeah. So yes. So now skewness kurtosis. This part is clear. So what we did, we have taken just calculated skewness and kurtosis values divided by this, and then you easily decide data is normally distributed. The second concept is Shapiro-Wilk value. Now see, look at the p value. Which value you have to look at? P value. P value. What is p value in this case? P value here 0.250. 0.250. If this p value If this is greater than, this value is greater than 0.05, which is our significant level, right? If this p-value is greater than 0.05, then data is normally distributed. Data is normally distributed. If this value is less than 0.05, data is not normally distributed. Simple rule. This value is greater than 0.05, data is normally distributed. If not, then data is not normally distributed. In this case, we find that this is 0.25. 0.25. If you don't understand the concept of this point, right, what you do is just multiply this by 100. If I multiply this by 100, this becomes 25%, and this becomes 5%. 25% is greater than 5%. Therefore, data is normally distributed. So this is second concept, that if you want to find out whether data is normally distributed using Shapiro-Wilk test, then what you will do, you have to just find out p-value. P-value, this is a p-value. So p-value for Shapiro-Wilk test is greater than 0.05, indicates null hypothesis cannot be rejected, right? So we have to accept null hypothesis and the data is normally distributed. Simple rule. How do we decide? How do we decide? Just check whether p-value is greater than 0.250. If it is greater than 0.250, data is normally distributed. Understood? So the first step for any statistical testing is check whether data is normally distributed. So in this case, this particular data of pH value is normally distributed. Okay, is normally distributed. That is what we have used Skewness test, kurtosis test, as well as the normality test, that is Shapiro-Wilk test. So by using all three tests, what we found that data is normally distributed. So it is a parametric data. Now, data, if it is a parametric type or parametric data, what now? Suppose we have to apply one sample t-test. Now, how do we decide one sample t-test? Let us work out now one sample t-test. Let us read this hypothesis. In this hypothesis, what is written? Null hypothesis, pH of wine bottle. This we had discussed when I gave an example of hypothesis. pH of wine bottle is significantly lower than or equal to the threshold value 3.5. Alternative hypothesis is pH of wine bottle is significantly higher than the threshold value. Now, when it is higher, right, higher or lower, it is one-sided test or it is one directional test. Now, what is direction? Higher. Higher means greater. So this is greater type of test, and we are going to compare with one value called as threshold value. So since it is one value, it is single sample test, right? Compared with a one significant fixed value, right? So we call it as a benchmark value. That's what it is. Now there are two chances. Either it is parametric or non-parametric. Few minutes before, we have seen that data is normally distributed. So we had two options. What are two options? Either we apply one sample t-test or we apply, just let's go back. What is the option? What are the options for one sample t-test? Either we apply benchmark value. So either if data is normally distributed, we apply t-test or Wilcoxon test. But our data is now parametric, that is normally distributed. So we are going to apply t-test. Right? We are going to apply t-test. That's what here we will be applying t-test for our testing purpose. So direction is very important, and then which test to apply, that is also very important. What we have decided, we are going to apply one sample t-test in this case. So let us go to the same file and apply this. So I'm now, first what I did, I have decided the normality. Now I'm finding out whether it is significantly higher. So on the top, you will see t-test, ANOVA, right? T-test and ANOVA. So let me just remove this. Already I have tested it, so I don't want this part. So we'll start. We'll go to t-test, and in t-test you will find out three options: pair t-test, independent t-test, and one sample t-test. So let's go for one sample t-test. pH again on the right hand side. I'm purposely using the same data so that you will understand it. Now here again also you can go for normality test. If you want to check once again, you can go for the normality test. See, few minutes before I was talking about this p-value. This p-value is greater than our significant level 0.05. So data is normally distributed. So here also you can check whether data is normally distributed or not once you know the hypothesis. Then, since our data is normal, we are having options here. You will see what are the options: student t-test, matlab t-test, and Wilcoxon rank test. Now, by default, student is selected, but that need not be. Since our data is normal, we are going to apply student test. So otherwise, ऐसे situations रहेगा, we have to apply this. I hope it is clear. I hope it is clear why I'm selecting student test. Yes, can somebody reply? Why I'm not using Wilcoxon test? This is non-parametric test and this is parametric test. Can somebody reply? Am I audible again?
Yes, sir, you're audible.
Can anybody reply? Why I'm selecting student test here? Why not Wilcoxon rank test? Okay, I'll tell you. The data is normally distributed. That's what I'm selecting student test. If data would have been not normally distributed, I would have selected Wilcoxon rank test. So here I'm selecting student test. Now look at the p-value once again. P-value here is less than 0.05, which is less than 0.05, right? My p-value is less than 0.05. And what is the rule of rejection? Null hypothesis ka rule of rejection is this, but still I've forgotten something. What is that? Very important thing here. Test value I have to write down. Test value is 3.5. This is your benchmark value. And our alternative hypothesis, what is our alternative hypothesis? Alternative hypothesis is significantly higher. So if it is significantly higher, I have to go for greater than. So this I have to select. Now all my choices are correct. Now see there is a change here now. There is a change here. What is earlier it was less, now it is greater. So my p-value is greater than 0.05. So if it is greater, I am not going to reject my null hypothesis, because what was my rule of rejection? Rule of rejection of null hypothesis. Let's go back. Rule of rejection of null hypothesis or acceptance. If p-value is less than the chosen significant level, then null hypothesis is rejected. Now in this case, p-value is 0.858. 0.858, which is not less, which is actually less than, this value is less, greater than, this value is greater. I want less. This value is greater than 0.05. This is 85.8% and this is 5%. 85% is greater than 5%. Therefore, null hypothesis cannot be rejected. For rejection, it should be less. Null hypothesis cannot be rejected. Similarly, I will go for, because of the time constraint, now I'll go for two sample t-test and paired sample quickly. Let me just go ahead with my now if it is two sample t-test, this is one sample t-test. If it is two sample t-test, what we can have, we may have independent sample or dependent sample. Suppose it is independent sample. Let us go for this one now. Hypothesis testing, where hypothesis is lymphocyte cell diameter is significantly higher or equal to higher than or equal to the diameter of the tumor cells. This is this. Something is greater. Now there are two groups. So I have to apply, and two groups are independent. So let me go for the another file where two groups data is given here. Remember that this data should be arranged in this particular way only. The first part is lymphocyte cell data, and second part tumor cell data arranged in the column. Diameters are given, not as a separate group. Please note this. So we apply independent sample t-test. How do we go ahead? Again, go to independent sample t-test. Select cell type of a cell as a grouping variable because that is going to segregate, and diameter as an dependent variable. Again, go for a normality test first. Check whether data is normally distributed or not. If data is normally distributed, we apply parametric t-test. If not, then we apply non-parametric test. Here, data is normally distributed or not. Yes, it is greater than. So for normality test, this value should be greater than 0.05. If it is greater than 0.05, we know that data is not normally distributed. For normal distributed data, we have to apply student test, and for not normal distributed data, we have to apply manual test. But in between two, there is one more test called as Wells test. Now, Wells test is applied. When do we apply Wells test? So after testing normality, once the data is normally distributed, we go for homogeneity test. Levin test it is called. Right? Again, the rule is very similar. This is for homogeneous data. If this value is greater than 0.05, then our data is 0.05. Then our data is homogeneous. And if it is homogeneous, I'm going to apply student test. If it is non-homogeneous, suppose this value is less than 0.05, then I will apply Wells test. In this case, I'll be applying student test. Let us see what is the result if we apply student test. Yeah, again, one more thing you have to check whether our data is having, one more thing you have to check whether our data is directional. So this is directional, less than type, lower than type. So if it is lower than or less than type, I have to select the second one, less than type. Then our results will be perfect. Let's see what are our results now. Again, you have to look at p-value. Here, p-value is less. So null hypothesis is rejected. P-value is less, so we are going to reject null hypothesis. We are going to reject null hypothesis. So null hypothesis is rejected. This is independent sample t-test. Once all these basic things are known to you, one can go for any type of testing. Now, let's go for independent sample t-test. Independent sample t-test is known to you. All results are given on my slides. We'll go for pair t-test immediately, just 2-3 minutes now. Pair t-test. Now, hypothesis testing, hospital. Now, this data we will go for paired one. So data is paired. Only thing is data is taken before and after. This is related to this stay in the hospital. What is estimated and what is actual. So again, we go here, select pair t-test, select pair t-test. Paired variables are this, two variables. We are comparing, we are giving the pairs together. Same procedure. Go for normality test. Select whether the data is, check whether the data is normal or not. Again, data value, this p value is greater than 5%. So data is normal. We have two options. If data is normal, student t-test. If data is not normal, Wilcoxon test. In this case, data is normal. So we use student test. Okay. Now we have decided test. Now what is value? This value is greater than 5%, 0.05. That is greater hai, so we are not going to reject null. We are going to retain. So here alternative is null is retained and alternative is rejected. Null is accepted and alternative is rejected. Finally, let's go for the last example. I know that I'm going really fast, but no alternative because it's time. Similarly, we can go for ANOVA now. ANOVA is used for more than 2 groups. So this is the data sheet, more than 2 groups. So there are 3 different groups which we have to consider for ANOVA. Procedure remains now: cell type A, cell type B, and cell type C. So for ANOVA, we have to select one way ANOVA. There are different types of ANOVA. I'm going for one way ANOVA quickly. It is an extension of t-test. So cell type will go here, output will go here as a dependent variable. Procedure remains same. Just check out normality. Data is normal, right? Here data p-value is greater than 5%. So data is normal. Then go for homogeneity test, whether data is homogeneous or not. If data is homogeneous, in this case, this value is again greater. So data is homogeneous. So for homogeneous, we have to apply ANOVA. See here it is written. Homogeneous ka matlab equal variance. Non-homogeneous matlab unequal variance. So here data is homogeneous. So we are assuming that data is having equal variance. So I'll be selecting this. Select this. Now look at this is F test. This is F test. This value is less than 0.05. Value is less than 0.05. Therefore, we say that null hypothesis is rejected and alternative hypothesis is accepted or rejected. That's all about using this thing for ANOVA and t-test. There are 3 types of t-test. So really you have to excuse me because of the time constraint I had to increase my speed. Madam, I am done with this my session. If there are queries, please ask.
Sir, we have received one question from the participant.
Just a minute.
The participant is asking, is there any sample limit to calculate test and Z test?
Z test is applicable when we have a large sample size, but for t test, if the sample size, even if the sample size is large, t test is applicable for unequal variance. So in majority of the time we use unequal t test because Z test is not applicable. In fact, for a large sample, Z and t are same. Z values and t values are same. So Z test is equivalent to t test for a large sample. Large का मतलब होता है greater than 30, and most of the cases we have more than 30 samples. So no need to bother about Z test. You just have to apply t test in that case.
Okay, sir. Thank you, sir. Participants, if you have any question, you can just unmute yourself and you can ask. Sir, I think we don't have any questions. I would like to invite Assistant Professor Sonali Singh ma'am to propose vote of thanks.
Thank you so much for such a statistical session. I would say it was like full of all the tests, parametric test, non-parametric test, and also like how we select, what are the different conditions when we go for one test over another test, whether it's your t-test, z-test, Wilcoxon test, and even like the steps, the way you explain hypothesis testing test. I think so now even we can think of doing a hypothesis testing using different tests and like utilize test of association, test of difference. So thank you very much, sir, for such an exhaustive and extensive session on, it's not possible to cover everything in 1 hour, but I think so, sir, through hands-on experience, through Jamovi software, you have given us enough knowledge where we can try. And all the tests when we are supposed to use Z test, T test, whether it's a homogeneity test or a normal distribution test. So thank you very much, sir. We would really try, and hopefully we will also be able to do a hypothesis testing using various tests. Thank you very much, sir, for the session.
Thank you, Sonali. Thank you very much. May I take your leave, madam? Hello? Can I leave this session?
Yes, sir. Yes, sir. Now we will start the second session.
Okay, thank you. Thank you, everybody.
Our second speaker for today will join soon. We'll start with in 5 minutes.
Resource person would be joining us in 2 minutes. I hope the participants have downloaded the R language software. And also, sir was expecting that you log in from 2 devices, one from laptop and one from mobile, while during the conduct of the session 2 and session 3. Sir has joined, so resource person has joined. We'll start this.
We will be starting with session 2 now. The session 2 is based on 2 topics. One is introduction to R language, followed by factor analysis, scale reliability, and principal component analysis. The speaker for the session is Dr. Raju Narayan sir. Sir is a retired professor from Department of Statistics, University of Calicut. He started his career as a teacher at Farooq College and then moved to University of Calicut. He has also worked as statistical expert at Ministry of Development, Planning and Statistics at Government of Qatar. Sir has various editorial works to his credit, like Proceedings of the International Conference on Stochastic Processes and its Application USA. He was also the guest editor of Journal of Engineering Simulation at Ukraine. Sir was the chairman, Board of Studies, PG in Statistics, also a member of Board of Studies, University of Calicut. Sir is a member of Board of Examinations at various universities and also a member of Academic Council at University of Calicut. Sir has guided total 5 students for PhD and also has 15 publications to his credit. We welcome you, sir, for today's session, and we look forward to your session. Thank you.
Good morning to all. Please permit me to share my screen. Okay, good morning to all. First of all, I express my sincere thanks to the principal and the coordinators of the program for giving me this wonderful opportunity to interact with the teachers and researchers. And I am given two topics for today's discussion. The first one is an introduction to R programming. And the second one is something related to data analysis, that is fact analysis, reliability analysis, etc. Please tell me how many of you are familiar with R programming? Please raise your hands. How many of you are familiar with
Participants can type their answers in the chat box, or they can even unmute themselves and speak.
I cannot see any hands, or
Sir,
I cannot
it's a
see any
mix.
message.
I feel not many might be aware because it's like a mixed crowd. Even the students are there along with the faculty members.
Okay, no
So
problem.
our language, they are not much familiar.
No problem. Okay. Now, I have seen the topics of this program, and many topics are related to data analysis, t-test. I know so many things are there. Hello. I am in Mufti, that is why I am not switching in as camera. I am in my house. Okay. Can you see my whiteboard? Can you see my whiteboard?
Yes, sir.
Very good. Now, our first session is R programming. Now, I think that you are all management students or computer science students or some researchers, etc. Therefore, in your coursework or as part of your research work, you have to handle data. Nowadays, data is very important in any research, and because of this technology, development in technology, data is generated in every second. In every second, data is generated from this planet, also from the outer space. Here you can see in every traffic junction, you can see some cameras. And the cameras are taking photos, and photos are analyzed, and immediately you are getting a message in your mobile phone. Such and such roads are very crowded, therefore you tend to right and go by that way, etc. You can save some 25 minutes, etc., etc. Live data analysis is going on. Live data analysis is going on. Similarly, if you look at share markets, every second, the things are changing. Again, if you look at the weather forecasting, they are collecting millions and trillions of data. And because of that data, and because of the very powerful data analysis technique, nowadays weather forecasting is almost error-free. Error-free. Okay, if they say that some low pressure is coming, etc., then it is coming. Okay, and the error is very less. Okay, and while we were students, we were doing this data analysis using a table called logarithm tables. Nowadays, nobody is using that one, or the school students may not be knowing what is this logarithm or what is this logarithm tables, etc. Nobody is using that. And because of that limitation, we were doing our practicals using 5 or 8 data. That is all. Because data analysis was very difficult at that time. Nowadays, very powerful computers are available in speed and in capacity and in memory, etc. Very powerful softwares are available. Therefore, the number of data is not at all a problem. And the complications in algorithm is not at all a problem. You can write very efficient programs and you can run your program and you can get your data analyzed. And in markets, there are so many packages available for data analysis. SAS is available, SPS is available, S+ is available, Minitab is available, Statistica is available, Stata is available. So many packages are available. And all these packages are commercial packages. They are very powerful packages, very good packages, but they are commercial packages in the sense that we have to pay lakhs and lakhs together to get the license to use that package. Before some 4 or 5 years, we can buy one package and we can use it for our lifetime. Nowadays, that facility is also not available. Every year you have to renew your license by paying. Sometimes it may be 20,000, sometimes it may be 50,000, like that. Depends on the package. In a country like India, where we have hundreds of colleges and millions of students, it is practically difficult to buy licensed softwares for teaching and research purpose, etc. We cannot afford that much cost in a college or even in a university. It is practically impossible. And thanks to some authors, they have developed some packages. They have developed some packages like R, Jamovi, etc., where we can use it for free, absolutely for free, for our learning purpose, teaching purpose, research purpose, etc. So many packages are there. And R is one of the packages. Very powerful package for data analysis. Very powerful package. So many Indian professors have contributed for the development of the R package. So many Indian researchers. Okay. And of course, so many others are also there. And I am sure that you might have downloaded R package in your system. Otherwise, it is very easy. Those who have not done, it is very easy for you. You just go download R. That is enough. Download R. It is already there. Okay. Now download 4.2.1. What is that 4.2.1? That is the version. Okay, version number. Okay. You click on that. You click on that. Here you can see download R 4.2.1 for Windows. Okay. And if you want the R package for your Macintosh system, you can select that one. If it is for Linux, you can select that one. Okay. It will be working on any platform. Okay. I have already downloaded R 4.2.1. Therefore, I am not doing that again. You click on that and I am sure youngsters are more clever people than people like me to download and install so many things. Okay. Then once it is downloaded properly, you can see R icon on your desktop. R icon on your desktop. Okay. You double click on that. The package is activated. The package is activated. Now here you can see a greater than sign. A greater than sign that is technically called prompt. Prompt, prompt. This is a place where we enter our data, our comments, etc. Okay, we are getting only 1 hour for discussion. Therefore, I'm making everything brief. First of all, I should say the help facilities. If you get help facilities, then without anybody's help, you can do it and you can learn it. You click on that. Here you can see manuals in PDF. Manuals in PDF. Okay. And the first one is an introduction to R. It is a 105 pages document. You can click on that. Yeah. Okay, 105 page documents. And here, so many examples are given. How to enter RAM, how to write our own file. So many things are there. So many things are there. And you can save these things on your desktop. You need not by heart it. You need not by heart it. As and when it is required, you open that document and refer to the particular page and understand. That is all. That is all. So many wonderful documents are available for free. The first one is the R book. The R book. It is a 1045 pages document. You can download it and you can save it on your desktop. Okay, 1060 pages. 1060 pages. You forget about 60. All those things are bibliography, so and so. There are 1000 pages. If you read 10 pages every day, you can become a master in 100 days. You can become a master in 100 days. Okay? That about help. So many things are there. Reference tables, data import, export, R language definition, writing, so many things are there. Don't worry about those things now. Okay? And another one, for help, you can type the topic and you can use the command help. For example, help plot. Help plot. What is help plot? Plot is the function to plot a graph. Help plot, then you will get all the details. Yeah. And help me. Yeah, you're getting all the help. It is a function. Mean is a function, how to use it, okay? And the most important part is that you can see one worked example here. At the end of the description, you can see one example. You just copy that. And go to R and run it. Here, you are getting the answer. This is what we have to do first. First, we have to see the techniques used by others. And then you understand and you do your problem. And you will progress like that and you will become a master in R programming in 1 or 2 weeks. Okay. Another thing I have to inform you is there are a number of inbuilt data sets available in R. Inbuilt data sets. Many students, many teachers, many researchers complain usually that they don't have any data files for practice purpose. If they ask for data, many of them will not give because if you go to a bank and ask for their data, they will not give. They will say that it is a confidential property like that, they will not give you. For your practice purpose, number of data files are available in base module as well as in many packages. How to get that one? You just type data, open bracket, closing bracket. Data, open bracket, closing bracket. And then press enter key. Yeah. These are the data files available. This is the name of the file, air passengers. What is the description? Monthly airline passenger numbers. BJ sales data. BJ sales lead. BOD, biochemical oxygen demand. CO2, carbon dioxide uptake, chip weight versus the different types of data from different areas, chemistry, physics, banking, marketing, so many types of many data files are available. I should say how to type this data file. Okay, in R, it is very simple. You just type data. There is a file called reverse, RIVERS. You type data first, within brackets, you type the name of the file, data reverse. Yeah, data reverse is now available. To see that file, you just type reverse. That is name of the file. Yeah, you can see all the data. You can see all the data. So many numbers are there. Now you don't know what is this reverse. We have to use help function. Help reverse. Help reverse. Help reverse. If you want help on some topic, okay, help on some topic, you type help bracket reverse. Yeah. This data set gives the lengths in miles of 141 major rivers in North America as compiled by the US Geological Survey. That means what? It is not a fraud data. It is not a dummy data. It is not a manipulated data. It is a data compiled by a responsible survey, US Geological Survey. 141 major rivers in North America. Usage is rivers. Okay, if you want to use this data file, rivers is the name of the file you have to use. Okay, a vector containing 141 observations. So you are getting all the details. You are getting all the details. Another data file, empty cars. Empty cars. If you want to see the data, what is to be done? You have to type empty cars. You have to type empty cars. You can see all the data. You can see all the data. All the data. Okay. Now you want to know the details. What should be done? Help empty cars. Help empty cars. You will get all the details. The data was extracted from the 1994 Motor Trend US magazine and comprises fuel consumption and aspects of automobile design and performance for 32 automobiles. Yeah. Therefore, this is the data related to 32 automobiles regarding fuel consumption. What are the data given? MPG, miles per gallon. Cylinder, number of cylinders, DASP, displacement, HP, gross horsepower, DRAT, rear axle ratio, weight, gear, car, etc. Therefore, these are the data given there. These are the data given there. Now, if somebody is interested in studying the relation between number of cylinders and miles per gallon, number of cylinders and weight, number of cylinders and horsepower, and if you want to know the regression relation, etc., you can study this one. Another data set is IRIS, data IRIS, a wonderful data set. You can study almost all the statistical analysis using this data set alone, IRIS. Okay, there is a spelling mistake. Iris data. Iris is a type of flower. Yeah, you are getting a big data file. 150 rows and 5 columns. Okay. If you want to know this Iris data set, help. That is the only way. Help Iris. Help Iris. Help Iris. Yeah, you are getting this famous Fishers and Andersons. It is a wonderful data set. IRIS data set gives the measurements in centimeters of the variables sepal length, width, and petal length and width. Okay, it is something like a data from botany. Okay, of 50 flowers. 50 flowers. Okay, and you know what is iris flower? It is a type of a flower. Okay, and it is used for classification purpose. Iris flowers. Okay, you can see Okay, these are the high-risk providers, different family. Okay, different family. Okay. Now, therefore, you don't bother about data. For all your learning purpose, for all your teaching purpose, you can use hundreds of data files available in R itself. Okay, you need not beg for data to others. Okay, it is already given. Okay, therefore, help file is there, data file is there. Now everything is with you. You can learn R yourself. But however, we are given some time to discuss something. Now I told you that R is a data analysis application, data analysis software. Now what is the input? The input is the data. Input is the data. We have to give the data. And we have to specify the analysis to be done, what analysis we want. All those things we have to do. The package is something like a very obedient friend or servant. I should not use the word servant. Obedient, a helpful friend. If we ask the package to do something, it will do without any hesitation. It will do. Okay. Then my next explanation is to how to enter the data properly. Okay. Here you can see this is called the console or console. Or console. Here we enter the data and the statements one by one. It is very difficult to redo. If you want to repeat some process again, it is very difficult. It is very difficult if you use R console. So that you can use an editor file. You click on file and you can see the second line, new script. New script. If you click on that, you will get a new screen. You will get a new screen. Here you can see R editor, R editor, R editor. Here we enter our data and the statements. Suppose you want to add 3 and 5. You just type 3 plus 5, that is all. You just type 3 plus 5 in the editor screen. If you want to execute that, you select that statement and right click, then you can see so many options, run, line or selection. Run, line or selection. You click on that. Here you can see the answer 8. You can see the answer 8. Okay. Then 5 into 25. Star is the multiplication operator. Then 5 into 25, you select that one and run. 5 into 25, 125. If you want to add 1 by 4 plus 3 by 4, then 1/4 plus 3 by 4. The slash is for division. Okay, 1 by 4 plus 3 by 4, you should get 1. Yeah, you are getting 1. Now you may ask a very simple question, sir, all these things I can do in my mobile phone, then why should I take a, no, this is just a starting point. This is just a starting point. Suppose you have to use the values you have created for future purpose, for future analysis. What is to be done? You have to save that value. It is very similar to the money we are earning. If we are earning some money today And if you want to use a part of that for your future purpose, what is to be done? You have to save that money in some banks or post offices like that. How to save in computer language? You know that it is in some variable names. It is in some variable names. Okay, you know what is a variable name. It is a memory address, so many things you know. Therefore, I am not explaining all those things. For example, suppose you have to save the value 100 in variable name A. Therefore, you just type A is equal to 100. A is equal to 100. What is happening? The value 100 will be stored in A. The value 100 will be stored in A. Okay. Now you execute that one. You select that line, right click, run. That is executed. That is executed. That means what? 100 is stored in A. 100 is stored in A. Now you cannot see that value. You cannot see that value. If you want to see that value, you have to type A. Then only it will come. Then only it will come. Okay. Then if you select that one, you can see 100. You can see 100. Therefore, this is a technique of taking some value stored in some place. You just type the name of the variable. You just type the name of the, what is a variable? Variable is one which is changing from unit to unit. Height is a variable. My height is different from your height. Your height is different from your friend's height. Therefore, it is varying from person to person. Therefore, it is a variable. That's all. Therefore, A is equal to 100 means what? The value 100 is stored in A. And if you want to see that value, you have to type A again. Instead of small a, suppose you type capital A. Then what happens? You will get an error message. Object A not found. Object A not found. What is the message from this example? R is case sensitive. R is case sensitive. R is case sensitive. That means what? Capital A and small a are different objects for R. Different objects for R. It has got its own positive side as well as negative side. What is negative side? Suppose you are using capital A and small a in the same program. And if you use capital A in the place of small a by mistake, it will take the value stored in capital A and it will execute the work and it will give you some value. Similarly, if you use small a in the place of capital A, it will take wrong value and it will do the calculation. That is the negative side. What is the positive side? You can have so many variable names. This is all these are different. All these are different for R. All these are different for R. Therefore, you can have with a small a and a capital A, you can have a number of variable names. But you should be very careful. Therefore, you have to use a policy. Whether you use small letters or capital letters, first one capital and all other small, etc. Okay, this is an important point regarding variable names. Next one, important point. Suppose you are a businessman and you are analyzing your sales, okay? And Monday sales, Monday space sales is equal to 280 units. 280 units. And if you execute this statement, you will get an error message. You will get an error message. Unexpected symbol. Unexpected symbol in Monday sales. What is that unexpected symbol? Space is an illegal character in the variable name. Space is an illegal character in the variable name. That is why you are getting this error message. You can use underscore or you can use dot. If you want to separate two words, you can use underscore or you can use dot. This is valuable. Monday underscore sales is equal to 200. This is valuable. No error will be given. Okay. And Tuesday dot sales is equal to 700. Okay. It will increase the readability. Okay. That is also valuable. So what are the rules you have to observe in creating variable names? No special characters are permitted. Okay, I'm sure many of the participants are computer science students and researchers, so you know all these things. Okay, for example, $1 day is equal to 400. You will get error message because dollar is a special character. Error. Okay, like that. And to increase the readability, you can use underscore to separate the words, or you can use a dot to separate the words. Suppose you have to use data for 1 month. Data for 1 month for the analysis. Data for 30 days. That is sales 1, sales 2, sales 3, sales 4, etc. Sales 30. You have to use 30 variable names like that. It is quite boring, no? It is quite boring. And we may make more mistakes. It will make our life very miserable. In such a case, you can use a vector. You can use a vector to represent the sales. For example, you just write sales equal to C. What is this C? Combine function. C is a function, concatenate function. You know, those who have studied C, C++, etc., you are using this concatenate of strings, etc. C brackets, sales for the first day, sales for the second day, sales for the third day, sales for the fourth day, sales for the fifth day, sales for the seventh day, etc. You can use like this. You can enter all the values as a vector. You know what is a vector? X is equal to x1, x2, etc. xn. Okay. Now, if you run this one, all the values are stored in the vector sales. Suppose you want to know what is the sales for the fifth day. Sales bracket, square bracket 5. Sales square bracket 5. You are getting 670. You check whether 340 is the first day, 560 is the second day, 654 is the third day, 890 fourth, fifth day, 670. It is correct. It is correct. This is how we are extracting data. We are extracting data from a long file. Long file. For example, if you look at reverse, data reverse, here, these are the values you are getting. 141 values you are getting. Suppose you want to know how many values are there. We can use a built-in function. Okay, many of you are familiar with built-in functions in computer packages. Built-in functions. What do you mean built-in? It is already available. It is already available. There are two types of functions. Built-in functions and other one is user-defined functions. User-defined functions. As the name suggests, built-in functions are already built in the package. We should know how to use it. That is all. User-defined functions means what? Many researchers have many problems. Their problems are their own problems. For all the researchers, for all the problems, for all the functions, it is difficult to make, it is difficult to create built-in functions. It is practically impossible. Therefore, the user can use his own or her own functions. That is what is called user-defined functions. Okay? And I will show a number of functions now. Length is a user-defined function to know the number of elements in the vector, length reverse. You should get 141, length reverse. If you want to find the average, mean bracket, reverse. It is very simple, mean. It is very similar to spoken English. Mean reverse, you will get the average length of reverse, 591.1844. If you want to find the variance, VAR reverse, mean, now variance. If you want to find the standard deviation, SD, it is as simple as this, SD. If you want to find the maximum, MAX, maximum value in the data set, so that you can easily find who is the first rank holder. Max will give you maximum 3710. Where is 3710? 3710, yeah, it is 3710. If you want to find the minimum, MIN, 135. If you want to find the maximum and minimum together, range reverse. Yeah, minimum is 135, maximum is 3710. If you want to make a histogram, reverse. Yeah, you are getting a histogram. If you are not happy with this color, reverse, color is equal to which one? Gold. Okay, nowadays gold is very expensive. Therefore, let us have gold. Color gold. Yeah, you are getting a golden. If you are not happy with the gold, some people are not happy with the gold. They don't like gold. They like sky blue. Yeah. And you can right click on this, copy as a bitmap or copy as a meta file, and you can take your dissertation, some Word file you can take. You can take your dissertation and right click and paste. Okay, and here you can edit it. You can reduce the size or whatever maybe you want. You can paste there, and you can write your paper or thesis, whatever maybe like that. Therefore, this is the advantage of using user-defined functions. Okay, if you want bar plot, what is to be done? Bar plot, that is all. B-A-R-P-L-O-T, bar plot. Name of the data. Name of the data. Okay. Yeah. Bar diagram. Okay. If you want scatter plot, simply plot. Simply plot. Yeah, this is a scatter plot. And you can change the color, you can change the shape of the points, whatever maybe. Okay. And another point is, suppose you are having 1,000 data with you. 1,000 data with you. Is it possible to enter all the 1,000 data at the time of execution? Practically difficult. Practically difficult. Suppose you want to run it again. It is quite meaningless to enter the 1,000 data again. You can enter the data in Excel. You can enter the data in Notepad. You can enter the data in MS Word. You can enter the data in SPSS or SAS, anywhere you can enter the data, and you can import the data to R at the time of execution. Okay, that is an important and useful technique. Okay, I shall enter the data in Excel. Okay, this is some data. This is some data. I shall do it for you in a new file. In a new file, so that the technique is very clear. You enter the data in an Excel file. Okay, first one is name. Okay, second one is age. Third one is height. That's all. Okay, name is AAA. Age is 56. Height is 170 centimeters. And name is BBB. Age is 35. And height is 180 centimeters. Name is CCC. Age is 40. And height is 156 centimeters. That is enough for me. It is an example only. Okay. You can save the data in a number of ways. Number of ways you save data. First, we do like this. Save as a text file. Text file. Here you can see text tab delimited. Text tab delimited. Text tab delimited. Okay. I am giving this example one. Example one. For the time being, I am saving this file on my desktop. EX1. See. Okay. The file is saved. Here you can see EX1. 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 Okay. Now, if you look at the properties, you can see the details of this file. Name of the file is EX1. Okay. And the file is a text document. And the location of the file is this. Size of the file is this, etc., etc. So many things are there. Now, what is my objective? My objective is to take this file to R. To take this file to R. Therefore, I have to inform R. My dear R, I have saved a file in some location, and you go there and bring that file. It is something like the work of a postman. If I want to send a letter to you, I have to write the address clearly. I have to write the address clearly. Then only the postman can deliver the letter properly. Okay? Therefore, you don't worry about remembering the location, etc. You just copy it. You just copy it. You just copy it. Now we go to R. We go to R. Okay? My data 1. Because this is my first data. My data 1. Read dot table. Read dot table. This is a function. This is a function used to take data from some other, saved in some other location. Read dot table. He is the expert to do that work. Bracket, you type the address on the envelope, Sri, etc., or Mr., etc. Okay. And then you give the name of the file ex1 dot txt. ex1 dot txt. Therefore, you give, now you are giving complete address, name, flat number, road number, post office, district, state, what those things you have given. Now you remember the first line, it was name, age, height. That is the header of the columns. The first line is not data. It is the column names. Therefore, we have to inform that also. Header is equal to true. That is, there is a headline in my data table. Okay. Then you have to change this direction, or you have to give 2 lines. Which one is easy for you? You can do that. You have to give double slash. Double slash. Okay. Now you select this line and run. And run. Yeah, no errors are there. No errors are there. Now you remember what is to be done to see the data? You have to call the file my data one. My data one. When you call the file, you can see all the data now. Yeah. AAA 56, height is 170, BBB 35, height is 180, CCC age 40. That is what we have saved here. That is what we have saved here. Yeah. AAA 56, 170, BBB, etc. The way if there are 1,000 data, on the first day you enter 20, second day you enter 300, third day you enter another 400, and whenever you get time, you enter the data and you save this file. Therefore, this file is always available. And after entering all the data, you import that data to R, and you can do all the analysis. You can do all the analysis. This is how you enter data in Excel and import the data to R and execute the comments. Okay. You can do any statistical procedure. Any statistical procedure with a one-word comment. With a one-word comment. For example, suppose you take data iris. Data iris. IRIS. Okay. Now you can see this iris data. You can see iris data. Suppose you want to find the correlation between sepal length and sepal width. Okay. You just use COR. Finished. COR. Iris dollar sepal length, comma, iris dollar sepal width. Okay. If there are no mistakes, yeah, you are getting a value. Correlation coefficient between COR will give you. Suppose you want to fit a regression line, LM will do. Okay. I shall give some name for that. R is equal to LM. Okay. I am doing the same thing. LM will give LM. What is LM? Linear model. Okay. LM tilde. And if you want to see the summary, you have to write summary R. Summary R. Then regression is fixed. Yeah, you are getting regression line intercept value, okay, and the coefficient of this and multiple R square, everything you are getting. LM will do your regression analysis. COR will do the correlation analysis. Okay. And how many more minutes I can take? It is already.
So the session 2 would be there till 12:10, and then the third session starts from 12:10 to 1:10. So if you want to give a break of 2-3 minutes and then we can continue, we can continue.
Yeah, I think it is better to give a break.
Okay, sir. Yes.
Okay.
Sir. So we'll have a 5 minutes break, sir, in between, and then we resume the next session.
Okay, sure. Now, yeah.
Yes, sir.
And I'm sorry that I couldn't give you a complete picture of R. Mm-hmm. I could give only the installation process and something about the variables, something about the helper files, something for the helper facility, and something for data, how to take data, how to take data from Excel, etc. Only that much. Okay.
So yeah, but
And,
it's a difficult topic to cover in 1 hour, sir, but you covered it quite well, sir, and like in a very calm, composed manner. So we have understood, and thank you for that particular thing, sir, because it's a vast topic. Even we understand to cover it in 1 hour is not an easy task.
I
but
need at least 25 hours.
Yeah.
Okay.
Yes, sir. Yeah.
Usually I am taking a workshop for 25 hours, 5 days, 5 hours.
Yes.
Okay. And in that case, we will do some justice to the topic. Okay.
Yes.
But
Yes.
now you know that there is a package R, and
Yes.
it is free. And it is
Yes.
very easy to use.
Yes.
If you want to find the mean, MEAN. If you want to find the variance, VAR. If you want to find the correlation, COR. If you want to find the regression, LM.
Yes.
If you want to find ANOVA, ANOVA. Okay. Wonderful, wonderful analysis. You can actually, if you spend 1 or 2 weeks with the R, and this graphical facility is very wonderful. I have never seen such graphics in any other package.
Yes, sir.
Any other statistical package like SPSS or wonderful packages available. Okay, and now it is 12:15. You please take 5 minutes rest. After that, we will continue with the reliability analysis and the factor analysis, etc. Okay, thank you.
So participants, okay, sir. So if you have any question, you have the option to unmute yourself or type in the chat box.
Yeah.
Participants can unmute themselves, and we start the session at 12:20.
Okay.
Yeah.
Surely
yes.
you will have so many questions. I'm sure, because I couldn't explain, but I'm sure that I have used all the 60 minutes allotted to me in complete.
So I think Ms. Sonali has received one question. She will just ask it. So 1 minute. Ms. Sonali has received one question from the participant.
Sir, can we upload a CSV file in R?
Surely. CSV file or Excel file or SPSS file, anything. CSV, no problem. I can show you in 1 minute.
Okay, sir.
Okay, file. I think I have already one CSV file on my desktop. I think this is a CSV file. This is a CSV file. What is the name of the file? NSC Data Global Book. Long name. Long name. I am a very lazy man. Therefore, I am renaming this one EX2. 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 Okay. And okay, that file is already open. Therefore, it is asking me to close that file. Okay. We have to obey it, otherwise it will not do the work. Okay. Therefore, I will take my address. Okay. This is the address. This is the address. EX2. Okay. And I have to write the address on the envelope. Therefore, this is the address. Copy. I will go to R. I will go to R. Okay. I will type. This is the advantage of using editor. Copy and pasting, etc. are very easy. Is my data 2. My data 2. Instead of read.table, I have to write read.csv. There is the only difference. Comma separated values. And EX2 ex2.csv. That's all finished. Finished. Let me see whether I have made some mistakes or not. Yeah, no mistakes are there. My data to my data to. If I have to see, I have to pray. Yeah, you are getting the data. You are getting the data. Okay, I may increase the width. I may increase the width. Okay, my data to yes. All the data is available now. Suppose you want to see only the first few lines. Head, my data to. You can see only first 6 lines. Head means our head. My data to. My data to. Okay, you can see the first 6 rows. Yeah, first 6 rows. If you want to see the last 6 rows, tail, head and tail. Head and tail. So that we can make it sure that we have entered all the data promptly. Tail, data 2. Okay. Then you can see the last 6 lines. Yeah. 1, 2, 3. There are 1,235 rows are there. If you use head, you can see first 6 rows. If you use tail function, you can see the last 6 rows. Read.csv. If it's a text file, read.txt. Okay, like that. I think I have answered your question.
Yes, sir. So there is no format limit or any restriction to load data from any format of the document.
Actually, there is no format needed.
Okay.
If you want, you can format your data.
Okay, sir. Thank you, sir.
You can specifically say first 6 columns name, next 3 columns age, next 3 columns height, next 3 columns weight, etc. You can format it.
Okay.
You can format it. No problem.
Thank you, sir. Thank you.
And you see, so many generous, service-minded people are there to help you. You can join any of the R group. Any of the R group. And if you ask a question, you should be very careful. Within 10 days, your mailbox will be full. At least you will get 100 files. You can do like this, you can do like this, etc. And even otherwise, you can do this type of things. I need not tell you because you are all experts. Okay, how to do time series analysis. It is an important analysis in business because every day you do time series and you will get at least 1 crore articles. How much? 3,300 crores, something like that. Okay, time series analysis in R, using R for time series analysis. You can see so many YouTube files are there, tutorials points are there, a guide to time series forecasting in R. So many files. You take 1 or 2 files, that is all. You take time series analysis. What is time series? Therefore, this is the data, and you can see this is the data curve, etc. You just copy this now, and you can see first that is what we have to do. First, see how the experts have done the work. Okay. And here, what is time series forecasting? Okay, and the seasonalities, you know all those things. And at the end of the description, this is the data, air passengers, January, February, March, etc. It is a time series. Time series means what? Data generated according to a set of time points. That is time series. Now, for the data set and the code are given. Okay, yeah. This is a model, auto-regressive integrated moving average model. Okay, like that. Yeah. Now you just copy the codes, and paste it on your R platform and see how it is running. Thousands, not crores of files are available. Crores of files are available. I tell you, within 10 days, you can become an expert. Within 10 days. Okay. And one more thing I can promise. This is my email ID. All small letters. Raju, University of Calicut. Raju Unical @gmail.com. You can send your doubts in data analysis as well as doubts in R programming. Surely you will get a reply. If I am not traveling or if I am not engaged in classes like this, immediately I will send you a reply. Otherwise, within 1 or 2 days, I will send you a reply. This is my word.
Participants are requested to note down the email ID.
Yeah. Raju, University of Raju Unical @gmail.com. If you have some data, what is the statistical tool I have to use, etc., you can ask me. I will give you the reply. Of course, at a free of cost. At a free of, you need not pay any fees for me for consultation. Okay, you please take a cup of tea and we will meet after that. When should we start? Now it is 12:25. Oh, I have taken more time. Okay, we can start at 12:30. 12:30 or 12:35? Which one is convenient for you?
12:30, sir.
Convenient for you?
12:30.
Okay, 12:30. Very good.
Okay, sir.
Sir, can we start with the next session?
Okay. Can you hear me?
Yes, sir, we can hear you.
Yeah. Now, we consider reliability analysis. The idea is very simple idea. Suppose you want to conduct a study to know the job satisfaction of employees in your company or customer satisfaction. That is satisfaction level of customers who buy your items. Anything like that. Usually you are preparing a questionnaire. Okay. And I think that some other professors will talk on that topic. That is, so many questions will be there. So many questions will be there. So many questions will be there. What's the purpose of this question? The purpose of this question is to understand the satisfaction level of workers in your company or the satisfaction level of your students in your class. You are preparing, okay, so many questions. Technically, that is called a tool. This question is called a tool. This is a tool to measure satisfaction level of employees. It's a tool to measure the loyalty, brand loyalty of the customer. So many things are there. And if you are making a tool, you have to make it sure that that tool is performing its responsibilities properly. The tool is performing its responsibility properly. What is the responsibility of the questionnaire? The responsibility of that questionnaire is to measure the satisfaction level of the employees. The responsibility of that tool is to measure the brand loyalty of the customers. And you want to know whether that responsibility is properly done by the tool. Okay? For that purpose, we are performing this reliability analysis. Okay? Can you see my screen? Okay.
Yes, sir.
Okay. Reliability concerns the extent to which a measurement of a phenomenon provides stable and consistent result. It is not consistent results. What do you mean consistent result? Suppose you are developing a tool to measure the job satisfaction of the employees in one company in Mumbai, and you are getting a result. And if you apply that tool in Chennai or in Bangalore or in Calcutta, you should get more or less similar result. More or less similar. That is why stability. Okay. In one place you are getting highly satisfied result, in another one poor, then there is no consistency. Then there is no consistency. Okay. Reliability is also concerned with repeatability. Repeatability. That is, if you repeat the study using the same questionnaire, you should get more or less similar type of results. If the same result can be consistently achieved by using the same methods under the same circumstances, the measurement is considered reliable. For example, a scale or test is said to be reliable if repeat measurement made by it under constant conditions will give the same result. Okay. Okay. Testing for reliability is important as it refers to the consistency across the parts of a measuring instrument. That's the first thing every researcher has to do. After preparing a questionnaire, they have to conduct a pilot study. Using the data collected from the pilot study, they have to check whether the question is good or bad. If the question is good, then only they have to proceed. Otherwise, they have to consult with the experts and modify the questionnaire. A scale is said to have high internal consistency reliability if the items of a scale hang together and measure the same construct. Okay. And there are different ways to find the reliability coefficients. The most popular one is Cronbach alpha. Cronbach alpha. Don't worry, it is a mathematical subject. Don't worry about the derivations. All the derivations, etc., will be done by statistics and mathematics students. You are all applied statisticians. Therefore, you should know how to apply the tool. That is all. Okay. And what do you mean Likert scales? There are two possibilities. There are two possibilities. You look at a question like this. Are you happy with your environment in the working place? There are two options. Yes, no. These are two options only. Either you will start yes, or you will click on no. Here, you are actually closing the door. You are actually closing the opportunity to explain more. You are actually not providing any facility to express more. Okay? Instead of having these two ones, you can have different options. Not at all happy. B, somewhat happy. C, neither happy nor unhappy. Neutral. D, happy. E, very happy. This is what is called a 5-point Likert scales. 5-point Likert scale. Okay, it is connected with the name of the scientist who has developed this technique. Okay, Likert scale. Nowadays, everything is very easy. Yeah, Likert scale. Okay. Okay, and you can see so many Likert scale. It was the psychologist Rensis Likert. Okay, and he is the scientist, American scientist who has developed this scale. Okay, now you can make it 7 points. Not at all happy, extremely unhappy. Okay, little bit unhappy, like that. You can make it 7-point Likert scale. Okay, like that. Okay, I think some other professor will discuss these things in your workshop. Okay, therefore, where is our okay? The most commonly used internal consistency measure is the Cronbach alpha. It is viewed as the most appropriate measure of reliability when making use of Likert scales. No absolute rules exist for internal consistency. This Cronbach alpha is a value. It is a measure, something to measure. Okay, and the value is between 0 and 1. If it is 1, it's a doubtful case. That is, you are manipulating something. Okay, because if it is very close to 1, what it is very good. If it is close to 0, means what? Our tool is very bad. We have to reconstruct the tool. But as a rule of thumb, if you are getting Cronbach alpha greater than or equal to 0.7, then the questionnaire is satisfactory. Questionnaire is satisfactory. Okay? And usually say excellent reliability, 0.9 and above. High reliability, 0.7 and 0.9. Moderate reliability, 0.5 and 0.7. Low reliability, 0.5 and below. As a rule of thumb, we take like this. Okay, and of course, different people have different opinion about these things. Now, I will show you how to run this analysis. Very simple analysis. Very simple analysis. Okay. This is a data set collected using a questionnaire. What is a questionnaire? This study was conducted by my friend, Dr. Harish. Okay. Annapurna Restaurant Customer Survey. Okay. And I often try new and different things. Strongly disagree to strongly agree. 7-point scale. 7-point Likert scale. I like parties with music and lots of talk. People come to me more often than I go to them for information about products. I try to taste fried foods. I like to go out and socialize with the people. Friends and neighbors often come to me for advice and about products and brands. I am self-confident about myself and my future. I usually eat balanced, nutritious meals. When I see a new product in stores, I often buy it. I am careful about what I eat. I often try new brands before my friends and neighbors do. There are 11 questions in the first part. lifestyle questions. Okay. And we want to see whether this tool is reliable or not. Okay. And I use SPSS. You know what is SPSS? It is Statistical Package for Social Sciences. Okay. And it is very easy. Very easy. Okay. I am saving this data on my desktop. Annapurna. Okay. I am taking that data to SPSS file, open data. That is an Excel data. Therefore, I have to inform that first. Desktop, Annapurna, open. Error action is in the open. There's another application. Okay, okay. It is already open. Okay. Therefore, I have to close it first. Okay. I have to close it first. Okay. Yeah, no data is available. No data is available. Then what is to be done? You click on Analyze. You click on Analyze. You click on Scale. You click on Scale. Analyze, Scale. Then Reliability Analysis. Reliability Analysis. The first 11 questions. First 11 questions. I think it is correct, 11 or 13. Yeah, 11 questions. The first 11 questions I select and I transfer here. Okay, if you want, you can click on Statistics. Descriptive for item, descriptive for scale, whatever things you want, you can select. Scale if item deleted. Okay, continue. Okay, finished. Finished. There are 400 response and Cronbach alpha is 0.558. 0.558. That means what? This tool is not a satisfactory tool. This tool is not a satisfactory tool to measure the attitude of the customers. If it is something like 0.7 and above, then it's okay. This is important. Cronbach alpha, if I deleted. That means if you delete the first item, Cronbach alpha will be 0.528. 528 means what? It is decreasing. It is decreasing. Okay, therefore it is not good. Okay, therefore if we delete this item, fifth item, then Cronbach alpha 0.562. Cronbach alpha will be 0.562. You can try that one. Analyze, scale, analyze, scale, reliability analysis. You delete the fifth item. And again you try. Then you can see Cronbach alpha is 0.562. 0.562. This is what we have to do before conducting the final data collection. Final data collection based on a questionnaire. Suppose you want to collect data from 400 respondents. You take a 10% of that, 40. You collect data from 40 persons and you conduct a reliability analysis. If you are getting a value like a 0.5, something like this means what? You got to sit again and add or delete some questions. Okay. Then you again do the same analysis and you see that the value is 0.7 and above. 0.7 and above. Okay. I will show you another data. Yeah, another data. Okay, analyze, scale, reliability analysis. Well, this is also data in Likert scale. Okay, and this is about the customer engagement. Okay, only 4. I am taking only 4. You can see the reliability is 0.860. The reliability is 0.860. Okay, it is good. It is good. It is good. It is good. 0.860 is a satisfactory high value, 0.860. And here, if I delete first item, I can see that Cronbach alpha is reducing, 0.809. If I delete second, Cronbach alpha is only 0.807, again reducing. Third item, if I delete, Cronbach alpha is again reducing, 0.823. That means what? These 4 items are, all the 4 items are important items to understand the quality of the information. Quality of the information. That means this questionnaire is a reliable questionnaire. This questionnaire is a reliable questionnaire. First, you have to make it sure that your questionnaire is reliable. Then only you can go for the complete final data analysis for your research purpose. Okay. Please. Somebody ask some question?
No, sir, it was a disturbance. Maybe we have muted the participant.
Okay. Okay. Now, if you have some questions, some points to clarify, you can ask me. Hello? Only the researchers have that posted. Or you can type your question in chat box.
Yes, so we'll ask the participants.
Yeah, one question is there. Let
Sir,
me
one
check
of the
what is-
participant has asked, how do we come to know whether questionnaire I framed is reliable or not?
That is what I am telling. You do this reliability analysis. If the value of the Cronbach alpha is at least 0.7, then you can make it sure that your questionnaire is reliable. If it is something like in my previous case, it was only 0.562. It is not good. Therefore, I cannot conduct the final study using that questionnaire. I have to check whether I have to add more questions or I have to delete some questions. Okay. Actually, preparation of the tool is the important thing. You please remember that garbage in gives garbage out. Garbage in, garbage out. If the data is not good, we cannot expect very good results from the data analysis. That is contained in the data. It cannot take something from the outer space. Therefore, you have to collect very good data. Is it clear, ma'am? Is it clear? 10% of the data. That is, if you want to collect data from 300 persons, you collect data from 30 persons first. Then you check the reliability of your questionnaire. If the reliability is satisfactorily high, that means if it is 0.8 or 0.9, something like that, you can smile. Okay, my tool is good. Then you can collect complete data. If it is 0.4, 0.3 like that, don't cry. Don't get disappointed. You modify the questionnaire and try again. Okay, that is the fate of research. Okay, research is what? It is a continuous process. Any other question? Any other question? This is the easiest way of doing things. There are so many techniques. So many techniques are there for reliability measurements. Okay. If the Cronbach alpha is 0.9 and above, excellent reliability. Another one more question is there. Okay. If you are getting 0.9 and above, it is very good. Your tool is very reliable, highly reliable. If it is between 0.7 and 0.9, okay, high reliability. Then also you can conduct your study. Moderate reliability, 0.5 to 0.7, moderate reliability, but you have to answer so many questions from the examiner at the time of Viva OC. Okay. Lower reliability, 0.5 and below means it is better to modify the questionnaire before doing the final data collection. Okay. There are different methods. Test to retest methods. Okay, split to half method. So many things are there. Although reliability is important for study, it is not sufficient unless combined with the validity of the tool. You have to give your questionnaire to 4 or 5 experts. They have to take questions one by one, and they have to say, this question is not important. This question should be asked before that question. Okay. They will suggest so many things. Okay. And statistical tools are what? Not that much powerful for validity. Okay. The validity can be ascertained by experts. Yes, you can have measures, but before that, you have to discuss with 4 or 5 experts in the same area. In other words, for a test to be reliable, it also needs to be valid. Okay, for example, if you have a watch, it is always showing wrong time. It is not reliable, it is not valid. Suppose your watch shows always 5 minutes fast. If the actual time is 10, it will show 10:05. If the actual time is 1, it will show 1:05. If the actual time is 6, it will show 6:05. Then your watch is reliable. Your watch is reliable. That is, if you see that the time is 3:55, you know that the actual time is 3:50. If the time is 7:15, the actual time is 7:10, but it is not valid. It is not valid. The watch is reliable, but it is not valid. Okay? Validity means that a test or instrument is accurately measuring what it is supposed to. If you want to measure the intelligence of a person using a questionnaire, that test should measure the intelligence correctly. Test to retest method means what? You conduct a test now. After 3 or 4 months, and if you are sure that the respondents might have forgotten the questions, you conduct the same test again. And you look at the correlation between the 2 scores. If the correlation is very high, means what? Your test is reliable. That is one technique. That is one technique. That is what test retest method. But it is very difficult to find the same persons again. They might have shifted their place. Okay, some of them might have died. Okay, so many possibilities are there. Okay, another possibility is split half method. Split half. I am running fast. Okay, internal consistency we have this. Okay, parallel forms. You prepare two forms of tools, questionnaires for the same purpose. Okay, some difference is there in the language, style, etc. But it is same. And you see the responses of the participants. Okay, like that. Okay, therefore, how to do that in SPSS? You take all the questions and you go to analyze, scale, reliability, and you take the questions, required questions. Okay, you take the required question to the box and simply click on that. Okay, and here you can see reliability 0.826. Okay, this is good. Okay, next one is factor analysis. Very important thing. Understand that factor analysis I need at least 5 hours to explain this. It is not a data analysis technique. It is not a data analysis technique. It is a data reduction technique. Data reduction technique. What do you mean data reduction technique? I shall explain. In general, there are two types of variables. In general, one, you can measure that variable directly. Direct measurements. Using some technique. Or using some tool. For example, height. Using a scale or a meter or something like that, or a tape, you can measure the height of a person. 175 centimeters, 165 centimeters, or 30 inch, 45 inch, like that, you can measure. Weight, you can measure. So much kilograms, so much pounds, like that. Number of items produced. You can count how many items are produced by the employee. You can count it 1, 2, 3, 4, 5, 6, etc. But there are certain other variables which we cannot measure directly. For example, job satisfaction. Job satisfaction. Can you measure this directly? And can you say that he is having 5 kilograms of job satisfaction, other man is having 8 kilograms of job satisfaction? No, it is not like that. It is not like that. Brand loyalty. Brand loyalty. You cannot measure this directly. Patriotism. You cannot measure it directly. Okay? Such variables are called hidden variables. Hidden variables, latent variables, like that. But if this property is there with a person, he will show some signs. He will show some signs or some symptoms, which you can measure directly. If I am satisfied with my job in Calicut University, I will show some signs. That is, every day I will come to office in time. I will take my classes regularly. I will conduct examinations and assignments, etc. regularly. I will participate in all the activities of the department. I will help my head of the department for the official work. I will celebrate all the celebrations in the department, etc., 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 etc. If I am not satisfied, then what are the symptoms I will show? Whenever possible, I will take leave and sit in my house. I will not go to the department. I don't want to see any faces in the department. I will not take classes properly. I will go to the class and I will fight with my students, and I will always quarrel with my students, and I will not take classes properly. I will not complete the syllabus properly. I will not conduct the examinations properly. Even if I conduct examinations, I will not give marks properly. Students will complain against me to the higher officials, grievance, etc. That teacher is like that, that teacher is like this, etc. That is a symptom of no satisfaction. If I am loyal to a brand, for example, Colgate paste, then whenever I buy a paste, I will buy only Colgate paste. On an average, I will buy 12 packets in 1 year. I will recommend this paste to my friends, relatives, my children, what are possible. Therefore, looking at the frequency of the purchase, looking at the volume of the purchase, looking at the value of the purchase, looking at the types of the paste I am purchasing, you can understand whether I am loyal to Colgate paste or not. Therefore, I will show some symptoms. Again, patriotism. I will show some symptoms. I will pay taxes regularly. I will obey the rules of the country. I will not say anything bad about my country when I go outside. If I have some objections, if I have some opinions, I will inform the authorities only. And I will express my points of view that this and etc. not good. Not in the public space. I will inform only at the proper place. Such and such things show that a person is a patriotic person or not. Because these things are not directly measurable, but there are things out of that factor. It is called factor. It is called factor. Then so many things are there. Frequency of purchase, volume of purchase, value of purchase, they are highly correlated. They are highly correlated. These highly correlated variables point out to the hidden variable brand loyalty of the customer. Job satisfaction, so many things are there. All those things are highly correlated, and those highly correlated variables point to the factor job satisfaction. Job satisfaction. If you are having 50 variables, then you will get a 50 by 50 matrix as the correlation matrix. 50 rows and 50 columns. By the time you reach the last value, you will forget the first value. It is highly difficult. I should say the word, it is practically impossible to interpret all the correlation coefficients. But if these 50 variables can be reduced to 4 or 5 factors, then interpretation is very easy. Understanding of the problem is very easy. What all the hidden things in the survey data, that is also very easy to understand. This is the overall idea about the factor analysis. Overall idea about the factor analysis. Okay. Then I will show you how to do that factor analysis using SPSS. Oh, now it is already 1:14. Can I take 10 more minutes?
Sir, by 1:25, we can wind up. If we can wind up by 1:25.
1:25. Okay, I can take 10 more
1:20,
minutes.
1:25.
1:20?
1:20 or 1:25 p.m. Till then we can.
Okay.
Yeah, yes.
Now in SPSS, you can easily do this factor analysis. Okay. Now, in factor analysis, there are no independent variable or dependent variable concepts. Okay. All are only variables. All are only variables. Now you click on analyze. Click on data reduction. Click on data reduction. Analyze data reduction. I told you it is not a data analysis technique. It is a data reduction technique. And click on factor. Click on factor. Okay. And you take all the variables of importance, all the variables of your interest. This I am doing, this data is okay. Then, if you want, you can take descriptives. No problem. Extraction methods, it is principal component methods. Rotation, you can select VD-max. Options, sorted by size. Finished. Okay. That's all. Very simple. All those things you can forget now. Okay. The last table is important. Rotated component matrix. Matrix. Here you can see there are 9 factors. There are 9 factors developed by this technique. Here, this is the highest value. That means what? This variable is highly correlated with the first factor. All other values are small. Again, this is comparing to the other 8 values, this is maximum. Now you look at these questions, then you will be really surprised. I really like helping other community members with their questions. I am motivated to participate in the community because I can help. I feel good when I can help. I like to know that my comments and suggestions can influence. I like to share my experience and knowledge with others. I hope to improve the brand product. Okay, increasing the influence I have on the brand and its product makes me want to participate. Now you can see among so many questions, 50 or 60 questions, you can see that these few questions are dominating in the first factor. You look at these questions again and again and again, you read 3 or 4 times, you can see an unseen thread connecting these questions. A connection between these questions. I really like helping. I am motivated to participate in the community because I can help. I feel good when I can help. I like to know that my comments and suggestions can influence the brand and its products. Okay, that means what? That factor shows helping and sharing knowledge of the customer. Okay, some 1, 2, 3, 4, 5, 6, 7, 8, all the 8 questions togetherly. As in the case of the frequency of the purchase, the volume of the purchase, value of the purchase, etc., point out brand loyalty. This one shows, these questions shows what? The helping mentality of the respondent. Now you look at the other one, comparing to other things, this point 733 is maximum. Friendship with other community. I am an important member. I am very attached. I see myself as part of the community, etc. That means what? It is something like a personality. Personality. That is, I feel that I am something important in the community. Okay. Next one, 0.774 is the maximum. Having conversation with other members who can share the same opinion is the interesting. It is important for me to have conversation with the other. That means what? Communication. Communication with the other members. Communication with the other members. Okay. And here you can see one by one. And what about the last one? I consider myself a valuable partner of the brand. Something like a leadership quality. Something like a leadership quality. That is, so many questions are there. These so many questions are different questions. But some questions are highly correlated, and these questions can be considered as a representative of the factor. Now, you have to give a name for the factor. Helping and sharing, leadership quality, okay, and participate like that. Like that. Therefore, these 50 variables are reduced to now 9 factors. Okay, I stop at this point because the time is 1:21. If you have some questions, you can ask me.
Participants can unmute themselves
and ask me. Because this is again a very long topic. Factor analysis, usually factor analysis itself will take at least 10 hours to explain. Okay, now I am putting everything in 30 minutes. Okay, one question is there. Let me check. Sir, what should be the count for pilot study? Usually you can take 10%. Usually. If you are taking 500 data for your final study, you can take 50 for pilot study. Because if you want to conduct chi-square test, etc., you need at least 5 frequency in a cell. Therefore, if you take 5 or 6 data, then such a test cannot be conducted. For at least 30 data you have to take. Any other question? Any other doubts?
Sir, I think
If you have no
our
other
sir has,
questions,
Miss Bhavna
I
sir
have
has
given already.
shared
I
his
have
email
given
ID.
already.
Yeah. So we
I
will
have
share it
already
on the
given.
group of the participants.
I have already given it. RAJU, all small letters. RAJU. You should be careful. Two U's are coming together. Raju, University of Calicut at gmail.com. At gmail.com.
It's also
If you have
been
no questions,
typed by Miss Sonali in the chat box. Those who want it, it is also written in the chat box. You can check it from there. Sir has also mentioned it again.
No problem. Okay. And madam, please share the presentations I have given to you with the parents.
Yes, sir.
With
We
the
will share in the
participants.
participant group, and sir also will share the link of the recorded session for the participants to review. Now it's my privilege to propose a vote of thanks. Yes,
no
sir.
need of that. I am also a teacher. You are a teacher. I am a student.
Nice, but it was very good, sir. Like I really want, like, sir, as a researcher, like it's a daunting task. Our language analysis, but sir, the way you taught via your calm and composed demeanor, you made it seem so simple. Like I was really feeling like a student listening to a professor, because you told it's such a calm, composed, and the analogy you gave. Otherwise, when we listen to our language, even as a research scholar, it's like a daunting language for us. But the way you brought it out, the way you taught us, sir, it really made a difference. It was such an intensive and informative and engaging session. And you made it look so simple, sir. It looked very simple. So thank you for a brilliant session, sir. Whether it was installing the brand, like you started from how to install the software, then how to find a maximum minima or the correlation or the variance, everything, like, and also the time series analysis, reliability analysis. Sir, I myself am teaching a research methodology subject, for factor analysis seems a bit tough, but the way you showed it, it really simplified it for us. And I'm sure we will try it on all the research scholar would gain from it, because they can also start. And you are sharing a PPT also. So thank you for a wonderful session. We are looking forward for more such sessions. And now I would also like to thank the management of the institute, our director, Dr. Mrs. Ansi Jose, our in-charge principal, Professor Dr. Moshmi Datta, and vice principal and IQAC coordinator, Dr. Mona Mehta, for giving us such a great platform and designing a 12 days capacity building program, which really is giving us and the research scholars, or like, it will help us in our research endeavor for sure. Because starting from the data, from the selecting a research topic, now we have reached a stage of data analysis, and it's a huge task, but the way resource person are making it simple, and they're trying it to explain it to us in the given stipulated time. So I think so we should really thank the management of the college, the resource person which we are getting, and my co-conveners and IQAC, I would like to thank too for designing this particular program. My co-conveners, Ms. Sonali, and Assistant Professor, Ms. Vishaka, and also the student who is helping us with the technical problem once we face. And last but not the least, our participants, our enthusiastic and patient participants who are always there, and without whom our workshop wouldn't have been complete. So thank you, participant, and looking forward to meet you tomorrow for the session on e-resources, how to use it for academic purpose and also impact factor and matrices. We will meet at 10 a.m. sharp tomorrow. Thank you, everyone. See you tomorrow.
1 minute.
We are posting the, yes, sir. Yes, sir.
1 minute. I also express my sincere thanks to Dr. Ansi, Dr. Sindhu, and the Dr. Principal, and all of the members of the faculty and the organizing committee. And last but not the least, all the 100+ participants for their patient listening and participating. Okay, because if nobody is there to listen, there is no need of, there is no meaning in taking classes. But I can see all the participants were there, and their cooperation and their participation, etc. Okay, thanks.
Thank you, sir. Thank you, sir, for taking out time and coming to our capacity building program. Thank you, Ms. Bhavna, for appreciating our like when we receive such a thank you note. We also feel great that we have designed the even we feel motivated to organize more such workshop in future. So thank you, participant. Attendance link has been posted in the chat box. You can. Yes. And also the documents which sir has shared with us, we have shared it in the WhatsApp group. So participants can check it over there. Okay, we will end the meeting by 1:30. The attendance link has been posted in the chat box. So participants can kindly fill the attendance.